So we're asked to find the zeros of a polynomial function in quadratic form. So we're asked to state the number of positive real zeros and turning points for the function g of x is equal to x to the power 4 minus 3x squared minus 4. So we need to determine all the real roots by factoring. So what can we say about our function? So the leading coefficient, so we have a 1 and it's positive, and we have a degree of 4. So therefore, because it's a degree of 4, the possible number of roots will be 4. And the turning point is going to be the number of roots minus 1. So the maximum turning point is going to be 4 minus 1, so that's going to be 3. So we're going to use the quadratic form. So this is, the quadratic form. So this is going to be AU squared plus BU plus C. So we're going to rewrite our function. So we have x squared to the power 2 minus x, so that's minus 3x squared, and then minus 4. So now we're going to replace, so we're going to let x squared equal u, and we're going to replace the x squared with u. So this will leave us with u squared minus 3u minus 4, and we can factor. So we got minus 4, and then we need factors that will give us minus 3. So that is going to be minus 4 and plus 1. So we're just going to rewrite this now. So that's u minus 4 and u plus 1. And now we're going to replace the u with x squared. So we're going to have x squared minus 4 and x squared plus 1. And we're going to make this equal 0. So we can solve. So x squared is equal to 4. So x is going to be plus or minus the square root of 4. So that is going to give us plus or minus 2. Or we will have x squared is equal to minus 1. So x is equal to plus or minus the root of minus 1. Now minus 1 is a complex root. So we're asked to find the real roots. So the positive real roots, we'll have two roots. So we've got 2 real roots at where x is equal to plus or minus 2. And then we're going to have 2 complex roots. So guided practice question. State the number of possible real roots and turning points of each function, and then determine all of the real roots by factoring. So the question, so we have the function g of x is equal to x to the 4 minus 9x squared plus 18. So we're going to use the quadratic form. So just going to rewrite. So we've got x squared to the power 2 and then 9x squared and plus 18. Now the real roots, the number of possible real roots, because this is a x to the 4, so the possible real roots is going to be 4, and the number of turning points is the degree minus 1. So that's the maximum turning points will be 4 minus 1, which will be 3. So going back to our function, I'm going to let x squared equal u, and I'm going to replace. So this will leave me with u squared minus 9u plus 18. And I need to factor. So factors of 18, that will give me minus 9. So this is 6 and 3. So it's going to be minus 6 and minus 3. So we'll have u minus 6 and u minus 3 is equal to 0. Now I'm going to replace, so we're going to replace u with x squared. So we'll have x squared minus 6 and x squared minus 3 is 0. And now we're going to solve. So x squared is going to be equal to 6, or x squared is equal to 3. So now we need to take the root of 6, and x will be the plus or minus root of 3. So this gives us, so we've got two roots. So we've got real roots at x is equal to plus or minus 6, or at and at plus or minus 3. Okay, so there's another question for you to try. So you can pause the video and answer the question, and when you're ready for the answer, then press play. Okay, so looking at this, we're looking for the leading coefficient, and we have a degree of 5. So the possible number of roots is going to be 5, and the maximum number of turning points just rewrite that, of turning points will be 5 minus 1, so that's 4. So the answer will be 4. So let's have a look at this question. So the first thing I need to do, because I need it in quadratic form, I'm going to factor by x. So if I factor by x, so greatest common factor by x. So we'll have x to the 4 minus 6x squared minus 16. And now I can use the quadratic form. So I'll have x squared, so make this a square bracket. So x squared squared minus 6x squared minus 16. And now we can replace, so we're going to let x squared equal u and replace. So we'll have u squared minus 6u minus 16. And now we're going to factor. So we're looking for factors of minus 16. That will give us minus 6. So that's going to be 8 and 2. And it's going to be a minus. So it's going to be minus 8 and plus 2. So this will be u minus 8 and u plus 2. So now I'm going to replace u with x squared. So this will leave me with x squared minus 8 and x squared plus 2. So we're going to make this equal to 0. So we have x is equal to 0, x squared minus 8 is equal to 0, and x squared plus 2 is equal to 0. So x squared is equal to 8, and then we take the square root, and we'll have x is equal to minus 2, and we have to take the square root, so plus or minus minus 2. So this is going to give us complex roots. So we'll have complex roots at plus or minus the root of minus 2. So there's 2 roots and the 3 real roots. So we'll have 3 real roots at x is equal to 0 and plus or minus the root of 8. And then the other are the 2 complex roots.